Hello everyone, my name is Harish Kumar and my student ID is 203200671. Today I will present my work for the PRES1 project in the CMP7005 programming for data analysis module. This project involved working with air pollution data from Beijing, China, where air quality is a significant public health concern. The main goal was to analyze the air quality and meteorological data, build a mechanic learning model to predict pollution level, and create an interactive application that allow user to explore the data and see prediction easily. Over the next few minutes, I will walk you through your entire process, starting with how I handling the data and follow through the application development and reflections. Let's begin with the data handling. Next slide. To start, I selected data from or different monitoring sites in Beijing. These sites were chosen to represent different type of involvements. Diagrams, urban, changing is suburban, pollution sources and conditions. I had to carefully pairs and the date columns so that the timestamps were consistently and correctly recognized as datetime objects. This step was critical to merge different databases accurately during loading. I also encountered encoding issues where some files did not read correctly at first. To fix this, I specified the correct encoding to prevent errors after successfully loading air quality data and meteorological data separately for each site. I merged them on their daytime column. This ensure each record contain both pollution measurement and weather data at same time. Next slide. After importing and cleaning the data, I explore the database to understand its structure and relationship. The database contains key air pollution PM2 and PM10, which are particularly matter particles of different size SO2, NO2, CO, and O3, which are GGS pollution and several meteorological features such as temperature, rainfall, wind speed, dew point, and pressure. Using correction analysis, I found that PM2.5 was strongly positively correctly with PM10, CO and NO2 with correlation correlation of 0.88, 0.77, and 0.66 respectively. This means these pollution often increase or decrease together. Likely due to common sources, temperature shows a negative correction with PM2, NO2, and CO. This suggests that higher temperatures might help reduce pollution level, possibly because of increased uh, depression and chemical reaction. Next slide. Uh, and I conducted behavior analysis to study relationship between pairs of variable using scatter, slots, and box plot. This helped me see how pollution relate to each other and to meteorological variables. I also performed multivariate analysis by using correlation, harems, and hair plots, which show relationship between multiple variables at once. Temporal trends were a key part of my analysis. I created line plots of pollution level by hours, day, and month to dedicate season and daily patterns. For example, pollution tended to be higher during morning and evening rush hours, reflecting human activity patterns. All these EDA steps help me a better understand the data source structure and variables, and also inform the future engineering process, the foundation was important to build a reliable model later. Next, uh, after EDA, I moved to machine learning to predict PM2 concentrations as it is a major pollution reflecting health. Before training, I scaled numerical features to have zero mean and unit variable using scan scalar. I also encoded catering variable as needed. I split the data into training and testing sets with an 8:0 and 2:0 ratio to improve the model's reliability. I applied cross validation during training, which reduce overlifting and ensure the model generalize well to new data. Next, to make the analysis accessible, I developed an interactive application using Streamlit, a Python library for building web app easily. The app was multiple pages, allowing users to navigate between selections such as data overview, exploring data analysis, and model prediction. User can view summers of data, explore different graphs, and input feature value to get live predictions from the training model. The app integrates visual libraries and metabolic seaborne and Plotly to create rich and interactive charts directly within the interface. I hosted the application code and data on GitHub, which makes it easy to manage version and share the app publicly. The Streamit app is lightweight and can run locally on a user machine on or be deployed to cloud platform for wider access. Next, the app is organized with a clear navigation, allowing user to switch between pages smoothly without reloading. The introduction page shows my student detail and give an overview of the project objective and data sets used. The data overview page presents simple record, column, and data types and codes of missing value, helping user understanding the few data at a glance. EDA and statics page including interactive visualizations such as line charts for trends, histogram for distribution, and attempts for correlation. These plots update dynamically based on user inputs. Next, through this project, I learned several important findings about being air pollution. PM2 level were highly correlated with PM10, CO, and NO2, which suggested that pollution organized from multiple sources such as vehicle emission and industrial activities. Meteorological factory like temperature and wind speed were negatively correlated with pollution, indicating that good weather helps disperse pollution. Urban and industrial areas continuously showed higher pollution level than suburban and rural areas, reflecting the impact of human activity. The Streamlink app provide effective in communicating a complex analysis result and enabling user to interact with the data and predictions. Next, this project also faced several challenges. The data and missing value and inconsistent forms, which required carefully manual cleaning and processing of ensure and accuracy. Merging metropolism local data with pollution data was tricky due to differences in timestamps, format, and recording intervals. requiring precise daytime alignment. Feature engineering was a challenge as I needed to be balanced, creating meaningful variables without over fitting in models. This required testing multiple feature sets and evaluating model results. Interpreting complex T-based model like XGB boost required additional validation using feature importance and cross validation to ensure reliability. Next, to keep my project organized and responsible, I used Git for version control and GitHub for cloud responsibility hosting. I structure the responsible clearly with the folders for a new data, uh, Jupyter notebooks, and Streamlit application script. I made frequent comments and detailed message explaining each update, such as adding new visualization, fixing hub, or improving model accuracy. This made it too easy to track progress, revert change if needed, and maintaining a clean history of the project development. Using GitHub also enables other to review and build upon my work, promoting collaboration and transparency. Mm, I include screenshot of my commit history as evidence of inactive version management through the project. Next, in summary, this project successfully analyzed diverse air quality and meteorological data from for beginning monitoring sites. I built a robot machine learning model using XGBoost to predict PM2.5 concentration with high accuracy. The Streamlet app made it easy for users to explore data, visualize trends, and get real-time pollution predictions. Finally, I demonstrate strong project management skills by using version control with Git and GitHub to organize my work. Thank you for your attention. I am happy to answer my question. You may happy. You may have.